Welcome to DDD. How many security talks does it take to actually make our applications more secure? Never enough. So here's another one if you were here before. My name is Janna Malikova. I'm from Brisbane, Australia. I worked with .NET and SharePoint and moved to open source about 10 years ago with React.js and Drupal and WordPress CMS. And about 6 years ago, branched out on my own as an independent consultant with Tomato Elephant Studio. So today we'll look at why cybersecurity is important, a quick look at the state of cybersecurity from a slightly different point of view. Then we'll look at the secure by design, what it is. And we'll look at the secure by design project, on actually how to start your projects with security in the mindset. And a quick action list of what to do next. So have you ever received a penetration test result? And do you even know how to prepare for a pen test? And what if your application is compromised? And do you even know if it has been compromised, and when, and how, and by who? And security always sort of feels like an afterthought, because it's really difficult to implement and really time-consuming when you have features in line. And the scope of security is huge. So you have physical security, which spans your hardware. You have network, cloud, infrastructure, systems security, the application security from design to development and to testing. And you have a data security. And you have human security. Can you even trust your developers or your third-party provider support people? So you need to think about those ones. But in this particular presentation, we'll just focus on application level security, and because it's a very short one as well, so on the application design from the security point of view. The quick review of the state of the security. So there's all this news coming out about Optuses and Medibanks and all of the other ones, but there's a bit quantitative measurement as a CVE program. CVE stands for Common Vulnerabilities and Exposures. So this is an initiative from American Cybersecurity Infrastructure Security Agency and lots of huge tech corporations like Google, Red Hat, and so on. So they collect in one place all the vulnerabilities that have been discovered and fixed, and those that have been actively exploited. So if we look at the 10-year span, 2025 is not looking that great. That was statistics from a week ago, or a couple of days ago. So we're already on the level of 2015, and 2024 was 40,000 vulnerabilities that have been discovered and actively patched. So we'll probably, in 2025, beat that, but maybe not. So that's why maybe we should think about secure by design. And secure by design comes in when security of the customer is a core business requirement rather than just a technical feature and afterthought. And secure by design is actually an initiative by Cybersecurity Infrastructure Security Agency from the United States and 17 US and other international partners. Australia is included in that. They recently celebrated 1-year anniversary of this initiative in October 2020. It was launched in October 2023. So their principles are the product should be resilient out of the box. Secure configuration should be a default baseline. And the complexity of the security should not be put onto the customer. So it's sort of, they put the analogy with the seat belts in the new cars. You shouldn't drive without the seat belt. You shouldn't just install seat belt as an add-on or anything like that. just the safety is built in. So we're basing on the security-first mindset, where we try to educate and be aware of the security and the threats. Also include security in the design phase of the product development. Employ the secure software development principles. A previous talk by Yaz was actually excellent about that. Implement the default security features and know actually what they are. Embrace transparency and accountability, so you know when you've been breached, and notify your customers quickly and timely. And implement vulnerability disclosure policies. If someone finds out a way into your system, they should notify you safely so that you can fix that issue. And also secure by design includes the catalog of product security bad practices. So everything what's wrong, everything what they found that some applications doing incorrectly, they put it into one fun read. Have a look at that as well. Also, Australia provided some guidelines for secure software development. They've updated it recently as well. And also, I based my Secure by Design project on technical guidelines from Open Worldwide Application Security Project, OWASP, the top 10, and they provide a lot of tools and resources on how to mitigate cyber attacks. They also provide an excellent web security testing guide so that it can prepare you for penetration testing and just focus on the specifics of secure features and secure coding practices, and the cheat sheets. Cheat sheets are really excellent because they focus on specific themes of the penetration testing and security. So based on that, I've created a Secure by Design sort of template project. So imagine you're starting a brand new project and you want to start it with the security in mind. How would you do that? First of all, set up your project in source control, GitHub, GitLab, or anything else that's available. You'll never lose your code. You'll track all the changes, so you will never find out. You can easily find out who did the change and when the change was done. And they provide lots of tools and features like project and task management, security advisory and scanners. GitHub and GitLab are excellent in that. And secret storage, so you can actually store your API keys in GitLab or GitHub and CI/CD and so forth. So it's excellent tools. And you wouldn't believe, but there's quite a few IT projects that don't have any sort of source control. So it's like HTTPS for everyone, Git for everyone. So let's set up a project, because when you put all the tasks in the project, you can track all the tasks and time, how long it will take to implement that. So in the previous talk, we had enable your dynamic and static security testing. So let's put that in the tasks as well. In another talk, there was all the secret storage. But it takes time to implement and set up the secret storage as well. So let's put it in the tasks as well into our project. Vulnerability disclosure. Who has security.txt on their web application? Very few companies and even government organizations do have security.txt attached to their web application. So this is your policy and procedure for white hat hackers to actually contact you and say, hey, you have all those things that might be exploitable. So just implement that. It's just one file that anyone can access, and they can actually tell you if there are any issues. So let's put those in the project as well. Authentication. Before starting with authentication, develop your strong password policy. Is there password expiration? Are you using third-party providers? Anything like that. And implementation of the enhanced security for users. Should there be a multi-factor authentication? Is there a login attempts limit? Is there a session limit? Is there auto logout? Can you prevent username enumeration? And things like that. So all of this can be broken down into more tasks to say, this is my authentication procedure and implemented lately. But that's just one big task. And another thing, as browsers mature, they create more and more secure features. For example, we have HTTP security headers that the application itself can tell the browser should some things be used or not. So you can easily test your web application with secureheaders.com and see which headers are missing and which headers you can implement to make sure that your application is more secure. And you can see, and that's big part of penetration testing as well, what the security headers are. So that some of those security headers are quite important. So for example, make sure you have strict transport security enabled and permission policy. If your website doesn't use a camera, why should it be allowed? So just disallow that so that your users can be happy, that the camera is not on. And also pen tests usually ask you to mitigate fingerprint application framework, so make sure you don't have server or what your application has been developed with or what sort of server it's running on. But it sort of goes into security by obscurity, which doesn't work anyway. And of course, if your web application, which is probably quite a lot of web applications using API or GraphQL, make sure your API is secure. Do you really need to expose all your endpoints? Have you configured cores on your server? Do you have rate limiting of how many times the same client can hit that endpoint? Is security configured? Do you have proper object level authorization and things like that? So that's an easy checklist to go through. It's not an easy to go through it, but at least when you have a checklist, you can make sure that you start your development. And some additional security features that might intercept with systems security or configuration. So if your users have to upload files to your web application, is antivirus configured and installed? Can you actually track who is trying to upload a virus to your system? And even if it might not be a virus where it's being uploaded to S3 bucket or to Linux, if someone downloads it onto Windows or some other operating system, it actually might turn out badly. And another task to add to the project is how can you prevent brute force attacks, enable captchas, or any other sort of ways for bots and click farms to flood your application with data. And you can add more and more to all these tasks if you think something that's already that you're doing or something that's relevant to your particular application. And then there's a production checklist mega task. So the Australian software development guidelines state that development, testing, and production environment should be segregated, so it shouldn't be just one server. All right, checklist. And development and modification of software only should take in the development environment. So don't do it in production. The configuration should be locked in production, and the development, the code should be just taken from your Git repo, that's it. Or if you create some sort of containers, just one. No one can just go in and type in something into your code. So make sure you follow those standards. And also when you're deploying it into production, make sure your super admin user may be restricted or even disabled. The development only and debugging features should be turned off. Any login should be done safely and should not be displayed to end users. So, and configured so that you can actually enable maybe monitoring and alerting for any logs. So this is a really quick 19 different tasks that we haven't even started writing the software, but these are the security, the bare minimum security requirements that may apply to your project. You can take some and maybe you can throw some out. So this will sort of build a security-first mindset when building the application. You can, if you are to implement all of those security features, you can start even estimation of this project, how long it will take. You will pick third-party component maybe for authentication, how long it will take to build in all the other features and things like that. It will also prepare you for pen tests and security compliance. And action list. So all the security vulnerabilities for your particular technology that you're using, they probably have a security advisory that's working, and they're notifying everyone who is subscribed to the advisory to make sure that you stay up to date. And once the vulnerability has been discovered and fixed, that's when you need to apply the patch or the new version. So make sure you subscribe to your security advisory. There is one Australian government, there is for .NET Core, there is for Node.js and things like that. So find one that is specific for your technology. Also have a look through the publications for the guidelines for software development from Australian government, the security by default tactics, and the WASP web security testing guide and the cheat sheets. You can also review your current code base based on above guidelines and on the tasks from the Secure by Design project. And the other one, try online security training or join community. So our WASP runs a lot of meetups in pretty much every capital city in Australia. So join them, and then you can become Secure by Design champion. So we've got, so I have all the resources in this little repo, so all the links to all the publications here, and all the tasks as well are defined in this GitLab repository. So you can have a quick review, fork it, use it as your own, or see where there might be a gap between security in your application and Secure by Design application, and what can apply.